Hi, this is Walter Stone. In this lesson, we are going to learn how to solve equations and application problems by factoring. I'm going to break this into two videos. So this video will be about solving equations, and then the second video will be about solving application problems. So we want to be able to solve after finishing this lesson, you should be able to solve equations by factoring and using the zero factor property. And so what we're going to do is look at what is called a quadratic equation. In general, we're going to be working with quadratic equations in this lesson. And a quadratic equation is a second-degree equation of the form ax squared plus bx plus c, where a, b, and c are real numbers, and a is not equal to 0. So the leading coefficient here is not equal to 0. If it is, the x squared term would be gone, and we would have a linear equation. But if we have an x squared term, it's called a quadratic. And if it's in the form ax squared plus bx plus c equal to 0, it's the standard form of the quadratic equation. And all in all, we always want to start off with the equation in standard form and work with it from there. And another key idea to solving equations of this type is the zero factor property. So it's a pretty simple idea. If we have two numbers that are real and they multiply to be 0, then either this first number has to be 0 or the second number has to be 0. So if we have two numbers that are multiplied and give us a product of 0, then either the first factor is 0 or the second factor is 0. And in math, we have this inclusive or type situation. So or both could be 0. And that's kind of what we do, is we use that either or both idea. So for example, if we want to solve x squared minus 3x minus 28, we first factor the polynomial, and then we use the zero factor property. So x squared minus 3x minus 28, we want factors of negative 28 that have a difference of 3, and those factors are negative 7 and positive 4. So we can factor this as x minus 7 times x plus 4 equal to 0. So we have two factors that have a product of 0. So what that means is that either x minus 7 is 0 or x plus 4 is 0. And if we solve this first equation, we can add 7 to both sides and get x equal to 7. And with the second equation, we can subtract 4 from both sides and get x equal to negative 4. So the solutions to this equation are 7 and negative 4. So if we put 7 back in the original equation, we'll have 49 minus 21, which is 28. Minus 28 gives us 0. And if we put 4 in here, we'd have, negative 4, we would have 16 plus 12, which is 28, minus 28 is also 0. So we can substitute these back into the original equation. And if we factored correctly, we should be okay here as well. So we just want to make sure we FOIL back, check our factors, and we'll have a good time with these formulas, with these equations. Okay? So we have some guided examples here I want to show you. So here in the first example, on the bottom of page 1, we have 7y plus 3y squared equal to negative 2. Now once again, we want an equation of the form ax squared plus bx plus c. So I'm going to write the squared term first, and then to get 0 on the right-hand side, this is essential that we get 0 on the right-hand side, I can add 2 to both sides of the equation. I then can factor, and 3y squared plus 7y plus 2, I looked for, I did some trial and error. The outers, 3y times 2 is 6x plus 6y plus 1y, is 7y. and the firsts I have 3y squared and the lasts I have 2. So I know I have the correct factors when I factor this into 3y plus 1 times y plus 2. I even factored that to the right here. So now we can use a zero factor property. Either 3y plus 1 equals 0 or y plus 2 equals 0. And here we're solving a linear equation now. So we can subtract 1 from both sides and get 3y equal to negative 1, and then divide both sides by 3, so y is equal to negative 1/3. This equation on the right of the OR is y plus 2 equals 0. We can subtract 2 from both sides, so y equals negative 2. So the solutions turn out to be negative 1/3 and negative 2. In equation 2, we have this is in standard form. C is 0 in this case. So what we can do is we can factor out a common factor of 5b. I have 5b times b minus 2 equal to 0. So by the zero factor property, either 5b has to equal 0 or b minus 2 equals 0. And if I want to solve for b, I can divide both sides by 5. And 0 divided by any number is 0, so 0 divided by 5 is 0, so b can be 0. This equation to the right of the word OR is b minus 2 equals 0. We can add 2 to both sides and get b equal to 2. So the solutions are 0 and 2. And in guided example 3, we have x squared minus 6x plus 9 equal to 0. And this is a trinomial square. So if I take the square root of x squared, that's x. The square root of 9 is 3, and the middle term is negative. So this factors as x minus 3 quantity squared. Now what happens is we have x minus 3 times x minus 3 equal to 0. So that means that this factor x minus 3 is 0. And I can add 3 to both sides to get x equal to 3. Now I call 3 a double root because I have 2 factors of x minus 3, and 3 is a root in each factor. So what is happening here is when we have a squared factor like this, we get a double root for the equation. And we'll come back and talk about this idea later when we talk more about solving equations and other types of, when we have quadratic functions, things like that. So I like to write, if I have a squared factor, I like to say that I get a double root. Okay, so this brings us to you having some time to solve and try these problems. And so try these 5 equations. I'm going to pause the video. You should pause the video and come back and check your work. So these are the solutions to the try these problems. So in the first equation we have x squared plus 8 equals 6x. We want to just make sure we write that equation in standard form. So I subtracted 6x from both sides, so we have 8x squared plus bx plus c. A is 1, b is negative 6, c is 8. And then I factored to x minus 4 times x minus 2. So if x minus 4 is 0, we can add 4 to both sides to get x equal to 4. Or if x minus 2 is 0, we can add 2 to both sides to get x equal to 2. So this should be, the solutions should be positive 2 and 4. Here's a Professor Stone mistake again. But this should be a positive 2 makes this factor 0, positive 4 makes this factor 0. So it's good to make sure we check. Okay. In problem 2, we rewrote, so we have standard form. So if I write the powers in descending order, we'll have 2y squared plus 5y equal to 3. We should subtract 3 from both sides, so we get 0 on the right-hand side. Now we have standard form. I found that the factors of this polynomial are 2y minus 1 times y plus 3. If we check that, we'll have, if we check the outers and inners, we'll have 6y minus y is positive 5y the lasts, we get -3, and the first term is 2y squared. So by the zero factor property, either 2y minus 1 equals 0, or y plus 3 equals 0. And if we add 1 to both sides and divide by 2, we get y equal to 1/2 for the solution of the first equation. And if we subtract 3 from both sides on the equation to the right of the or, we get y equal to -3. So -3 and 1/2 are the two solutions to that equation. And in the third equation, we have a common factor of 8b. So we have 8b times b minus 2. So 8b is 0, or b minus 2 is 0. So we can divide both sides by 8. 0 divided by 8 is 0. And to the right of the or, we can add 2 to both sides and get b equal to 2. So 0 and 2 are the solutions to that equation. And in equation 4, we rewrote to get standard form. So check that we can write the terms in descending order of x, and then we make sure that we have added 10x to both sides, so we have standard form. And this turns out to be a trinomial square, so this is x plus 5 squared, and that means that x plus 5 has to be 0. So we get -5 as a double root because we have two factors of x plus 5. So we have that double root idea again. And in problem 5, we have a difference of two squares. So 4x squared minus 9 can be factored as 2x plus 3 times 2x minus 3. By the zero factor property, that means 2x plus 3 equals 0, or 2x minus 3 equals 0. So to solve the equation on the left-hand side of the or, we subtract 3 from both sides, and then we can divide both sides by 2. So we get -3/2 as a solution. And to the right of the or, we can divide both sides by 2, and we get 3/2 as a solution. So differences of two squares give us that idea that we get a negative root and a positive root when we factor those. And so we'll also work with that idea when we look at other ways of solving these types of equations as well. Okay, so this is part 1 of this lesson. And so there are written exercises to practice, and you'll have some online practice as well. Okay, so I will see you in the second part of this video.